We have Julius now giving a talk about Prometheus. I'm very excited about this. I will let you introduce it.
Thank you for the invite. First of all, I'm actually curious, who is using Prometheus? Oh, like half the room. And who is a beginner? Oh, great. Okay, so you're okay. Good. Then at least it's maybe relevant for half the room. Perfect. I was not sure, would there be any Prometheus people here? Maybe they're experts already. Anyway, so welcome. I'm Julius. I'm co-founder of the open source Prometheus project, and I'm also the one person behind the company PromLabs. It's just myself. I'm just doing some training services and like online courses around it. Obviously, there's like many other companies also doing stuff around Prometheus these days. I want to talk about a couple of best practices. Today, I'm using this marketing pitchy title, 6 mistakes to avoid. So you click on the video. So basically, I always like to use this anecdote here. Prometheus in the ancient Greek myth was a titan who stole the fire from the gods, and obviously it was really cool. He brought it to the humans, and then they had fire. But the gods didn't like it very much, and they tied him to a rock where he was for all of eternity, and every day an eagle would come, eat his liver, and the liver would regrow, and then the same ordeal would happen the same time again. So it's the same with the monitoring system. Sometimes it feels like in the first picture where everything is illuminated and you know everything works well, and sometimes it's more like in the second one where everything's just painful and hurting. So in this talk, I'm going to aim to make you feel a little bit more like in the first picture. And this talk is for people who are already kind of using Prometheus and who are familiar with some of the concepts. If you're not, I apologize. But maybe it's still interesting. The first mistake that you can run into, or that everyone runs into when they start using Prometheus, is cardinality bombs. Prometheus is a monitoring system that only can track numeric metrics, and they are identified by a metric name, and then you can split up a metric name by a bunch of key value pairs that we call labels. These labels are really useful because they allow you to really dimensionally identify where something really is coming from. In this case, maybe you're a developer, you're instrumenting, like you're adding metrics to your HTTP server, and you want to know for every HTTP method, how many requests have I received? So you add this method label to your counter metric, and you just split it up, by the different methods, and that's totally fine. Oops. And then maybe the next day, some other developer comes along and thinks like, hey, it's a really good idea if we could also track for every request, like which user actually did it, and like count these by user. And like, unless you have only a handful of users, probably you run into trouble now because maybe you have millions of users or even billions if you're really big. And yeah, then you have millions of different values in this label, the user ID label, and that blows up the number of time series you have, because these millions of users get multiplied with the other label cardinality that you also have, so ×4 for the like post, get, put, and so on. Yeah, and then what you end up getting is your Prometheus server is exploding, basically. So you get an out-of-memory OOM situation. It goes boom. Or you hit some other limits that you have configured before, but often it is this, unfortunately. And yeah, what you just really want to watch out for here, right? Like you need to be aware of the fact that every unique set of labels paired with the metric name automatically generates a metric in Prometheus that the Prometheus server will happily automatically like create and index and process for you. And if you just put like an unbounded number of values into a given label, like the user ID label that we saw, then Prometheus will try, but eventually it will fail. It'll hit the limit, and maybe it will be the memory limit. That's the frequent one. So you want to try to avoid putting like stuff like public IP addresses in there, or public user IDs if you have more than like 5 testers or so. Full HTTP paths is something where you sometimes don't think about it in the beginning. You just think like, I have a few paths on my app. But then what ends up in the paths is often like some IDs, right? Like SoundCloud, some SoundCloud developers where we started building Prometheus initially, they tracked HTTP paths, and then the SoundCloud track ID was in the HTTP path, and SoundCloud had 100 million tracks at the time. So that didn't work out too well. And then, yeah, so you just need to be aware of this fact, right? These different cardinalities. Cardinality means just like how many different values you have per label. They multiply together between the different labels on a given metric, right? The, 4 methods times 1 million users kind of thing. So you have to multiply all these together. And you want to keep all those label values somehow well bounded. You should have some idea at least of how many different values roughly a label can take. Overall, there's no hard limit for how many different values you can put into a given label, but you have some rough limits to work with in a given big, beefy Prometheus server that has a lot of RAM. Rule of thumb there, a big server can handle like a couple of million of series that are concurrently active at the same time. Some really big servers even do like tens of millions or more. But for normal vanilla Prometheus server, that's not that common. And then you also want to be able to query all the time series belonging to a single metric name in a single query, and see them at least in a tabular form. And for that, it's good in a single metric name to maybe keep it to a couple of tens of thousands of time series, maybe even less. And yeah, generally just choose the metrics that you expose, the labels on those metrics, and then the number of targets that you expose those metrics on, which is another multiplier, accordingly to stay under this budget somehow. And then you're free to do whatever you want within those limits. Second one, missing 4 durations in alerts. I'll explain what that means. In Prometheus, you can define alerting rules where you give the alert a name, and then you provide a PromQL expression, and that expression defines whether something is wrong or not. If it produces a time series, one or multiple time series as an output, those time series will become an alert. And if the output is empty, everything is fine. In this case, we want to alert on any up metrics that are 0, meaning like that an instance, a process that we're trying to monitor is down. And if you just write it like this without any further modifiers, then a single scrape that Prometheus tries for a given monitored target, so Prometheus actively tries to pull metrics or scrape metrics from your processes all the time, and then the single scrape will immediately cause an alert when this alerting rule is evaluated. So there, it's a good idea to add another little modifier to this alerting rule called for. That's another YAML field that you can set your duration for which a given time series needs to be present in the output of this PromQL expression for it to turn from a pending alert to a firing alert that you actually get to see. And yeah, I mean, that's kind of the obvious case, but then there's also cases like this one where you already have some time averaging baked in to your alerting rule. Like you have an error rate and you average it over 5 minutes here. And you think, well, there shouldn't be any spike. Like I'm already averaging over 5 minutes, so it's already smoothing it out a little bit. But if you consider what happens when you have a completely fresh Prometheus server that doesn't have any data yet, or one that has been interrupted for a while and hasn't been scraping for 5 minutes, then what can happen is that this 5 minutes window that you try to select here only really selects 30 seconds of data that you really have. And then those 30 seconds, the development in there of the counter gets extrapolated over 5 minutes. So you might get something way higher than you expect. And so even a short spike that's just like 30 seconds long could alert you immediately. So even there, in those cases, you want to have 4 durations of a couple of minutes. It's always a good idea. I could make this case for many other alert types as well. So like generally in most alerts, you will want to have a couple of minutes of this trigger happiness tolerance delay in there. Number 3, aggregating away too many useful labels, especially in alerting rules. So a thing that often comes up when you write alerting rules with Prometheus is that you have a lot of individual rates over different methods and status codes and so on. And maybe you want to alert on like some overall error rate. So you sum all those rates, individual time series, into one big one with a sum aggregator. And by default, if you don't specify any modifiers on that aggregator, it will just munch everything together into one number, no labels anymore. This is the total rate. And maybe you really want only that one time series, but it would still be useful to keep some of the labels, namely the ones that are shared among all the inputs. So they don't really, they don't vary in the input. The job one is one of the most common labels. It's used in Prometheus often to designate the service that something came from. So it's very useful later on, once an alert makes it to the alerting pipeline, to route the alert, to silence it, to know which service or job it came from. It could also be in your infrastructure. It could also be different naming. And so like this one's always good to preserve, but on Kubernetes, you might also have a namespace label and things like that that will be common, useful, informational labels on all the info time series. So it's good to have a by modifier to preserve those labels that don't really change the output cardinality, but still preserve useful info labels. And even better than using by is using without. That is kind of the opposite of the by. So by is an include list where you just list the labels you want to keep. Whereas without allows you to only remove the labels you really want to get rid of. So in this case, we want to aggregate over all the process instances, but keep all the other labels like namespace and job and all those cool things. And then later we can group and silence and do useful things with them. Mistake number 4, using unscoped naked selectors. We see we're going through this pretty quickly. So selectors, I'm talking about metric selectors here. When you have this kind of construct, like in the middle, HTTP request errors total, that's the metric name, and then you can also have labels on it. If you only select the metric by its name only, that, many people do that. It's like, oh yeah, cool, I get the time series that I want. The problem is like this metric name only really has a single defined meaning within one code base where it's instrumented. So like within one service often that you're monitoring, and maybe tomorrow another team spins up another service that's monitored by the same Prometheus server. They use accidentally or through some library the same metric name, and maybe you really only want to monitor your specific service and not theirs. And so now if you have this naked selector that is not further scoped, you run into the danger of this maybe working today but not anymore tomorrow. So it's always a good idea to scope your selectors specifically to the service that you really care about. Often that will be the job label, but it could be, depending on your Prometheus configuration, that this is some other kind of constellation of labels that uniquely identifies the processes that you really want to monitor. Otherwise, right, you might suddenly select more data than you want and maybe alert on some other team service. Mistake number 5. Using rate and friends with gauges. So PromQL, the Prometheus query language, has a number of functions that tell you how fast the counter metric goes up. Counter metrics are these raw metrics where basically they're a type of time series that is only ever expected to go up. Cumulative counts over all of time, like a process starts and it counts its requests that it's handling, it goes up and up and up and up. The only time that they go down is when a process restarts, because it's only kept in memory, and then the process restarts and the counter starts at 0 again. Now what these functions do is they're only designed to work properly for these counter metrics, where the only time they decrease means it's always a reset. So they have this counter reset handling and correction built in. Whenever they see, like if you have a rate over 5 minutes, like this would be this green window, and they see the raw data points, and they see like, hey, under this window, the time series actually decreases in value. Then they will assume this was a counter reset, and they will try to compensate for that as much as possible by adding this new value to the previously seen value, because we assume we always reset back to 0. And so rate, irate increase, they will always only give you back positive results, or at least never anything negative. So if you try putting a gauge metric in there, a gauge metric is a metric that can naturally go up or down. Memory usage, queue lengths, disk space, temperatures. Maybe you also want to know like how fast are they going up or down per second. These functions don't work properly. They will not give you an error. That's the tricky part, because unfortunately on that level, PromQL is not typed. They will give you just an incorrect result. They will always give you something above 0 or 0. But if your memory usage, for example, is trending down, then they will still give you something either 0 or positive, because they think, oh, yeah, a decrease in value is a counter reset, and we'll just like try to neutralize it away. So you just have to be careful to use them only with counters. Vice versa, there are functions that only work correctly with gauges. Deriv, for example, gives you the per second increase or decrease of a gauge metric. And, so this can actually get negative. Like you could get something like, my memory usage is going down by 10 bytes per second or so. And yeah, if you try to stick a counter into those, they don't have any concept of counter reset detection and compensation. So, if a counter has a reset, you might actually get a negative request rate of this. So you don't want to use those with counters. Predict linear, similar, like this tries to predict a set of gauges into the future, and it internally uses a similar kind of slope calculation as Deriv does. So also doesn't work with gauges. So again, you don't get an error in this case. You just need to be careful to use them with the right metric type. And the last point here, mistake number 6, too short rate windows. The rate function is kind of the most popular function in the PromQL world because a raw counter value is never useful. Oops. Let's go back here. Right, you have this raw counter just going up, and the absolute value just depends on, like, does it get started 5 minutes ago or a year ago? It will be wildly different. So you always want to know just like how fast is my counter currently going up over some kind of moving window. And that's what you use the rate function for. But the rate function, similar also increase or irate or these other ones that kind of look at a metric and see how it develops over time, they need at least 2 samples under the provided window. That's this in square brackets 5M thing, for example, that we saw earlier, to see a development, right? The single sample is not enough for that to calculate a delta. So yeah, what happens if for some reason we end up with not 2 samples for a time series under the rate window? Then the rate function will simply provide an empty result for that time series at that point in time. So in the table, you would just not see that rate being listed, or in a graph, you might see a gap if at a given resolution step, the window doesn't span 2 samples. For example, if you have a bad scrape and your rate window is rather short, then you have unreliable rates resulting from that. Here's a couple of examples. Imagine you have the underlying data resolution at 15 seconds. That's how often we scrape. And now we, at all the different resolution steps over the graph, we kind of move a 20 seconds window over the actual underlying available data. Sometimes this 20 seconds window will span 2 data points that are 15 seconds apart, but sometimes it will not. And at the points where it doesn't, you have these gaps already developing. So like 20 seconds is definitely not a safe window for a 15-second scrape interval. If we make this smaller, like 16 seconds for a 15 seconds interval, then we only get an output once in a while. If we make it 15 seconds and 15 seconds, then you just get empty data. So yeah, you want to make sure, in general, to make your rate intervals big enough to robustly span at least 2 samples. So you want to make them a little bit larger even to tolerate an occasional failed scrape, bad window alignment, stuff like that. So overall, my recommendation would be use at least 4 times the scrape interval for your rate windows. If you are using Grafana, which you probably are, if you're using Prometheus, then there's also this great template variable that they have in Grafana called $__ rate interval, and that kind of automatically tries to give you a good rate window length. It kind of tries to make it not too small. So like, if you configure for your data source what the scrape interval is, then it makes it at least a couple of times the scrape interval. That's the minimum. But other than that, it tries to make it larger. The larger the resolution of the graph gets. Like if your graph only has like 10 resolution steps, then you need to make the window large enough to at least span the duration of that resolution step to capture all the data in that space, and a little bit larger even to capture possible increments from one window, from the end of one window to the next. So there's like slight overlaps between those steps. Anyway, you don't need to know that exactly, but this variable, if you just use it instead of a hard-coded 5M, you'll get like pretty decent results all the time. That was already it, I guess. Thank you very much. And any questions about Prometheus in general? Yeah.
I think it was like number 5, or to go back to the counters and pages.
Oh, with this one, or yeah.
So you talked about how, yeah, for example, these functions only work for counters and don't use gauges, and then the other one as well, or the other way around. And is that possible to have it built in from PromQL to detect, like, I don't know, this doesn't work?
Yeah, so unfortunately, the language isn't typed on that level because the metric types are more like the semantic meaning of a time series. Currently, in most parts of the stack, at least, I built this PromLabs tool, which you might have heard about, where if you try to do that, like, let's take the rate function here, and I'll zoom a little bit. Let's see, yeah. And you try to stick a gauge in there, like some memory usage, like this one. Like, hey, tell me how fast the memory usage is going up or down. Then this applies a heuristic, little warning here, like, because it looks at the metric name, and there's like, at least if you follow the conventions, it doesn't look like a counter metric. Counters usually have either underscore total, underscore bucket, underscore counter, underscore sum. And so it said like, oh, you know, like rate is only meant to be used on counter metrics, but this does not look like a counter metric. Did you maybe mean the deriv function? Then you can click here and it changes it. PromLabs used to be a commercial product of my one-person company, but by now it's open source. It's part of Prometheus. So it's not in the server, but you can run it. You run it as a standalone open source thing, and you point it at either directly at a data source or through Grafana. You can connect it through Grafana, and then it automatically can use the data sources that you have in Grafana. But that's not perfect, right? Like if you don't name your metrics perfectly. Maybe in Prometheus 3 or 4 or whenever that happens, we can have like more strict typing on the metric type level, and that would be great, actually. Yeah. Anything else? Any others? No. Thank you for your question. Oh yeah.
Regarding the sharding of Prometheus, what's your recommendation to say, okay, when it makes sense to say we need several instances, and when it doesn't make any sense?
Yeah. So like scaling and sharding, especially for scalability reasons, right? Like, yeah, I mean, like you can get, so probably not the perfect answer, but it's mostly you notice it when you need to need multiple servers, because like one is just like exploding left and right all the time because it's like just needing more and more and more RAM. And first you start like maybe talking to developers to produce fewer metrics, but at some point you're like, okay, we just need multiple. Originally, the idea for Prometheus was really you just run many of them, and like every team has their own. Like at SoundCloud, even when I left back in 2015, we had like 50 Prometheus servers. Like every team had like one or multiple for their different services. The downside being that then you don't have like one big coherent database that you can go to find everything. Whereas now, like I guess you know Thanos, right? Yeah, you're pretty knowledgeable. Like there's different solutions to help you integrate that data again on top of multiple sharded Prometheus servers. And then there's also more centralized solutions like Cortex, Mimir, and so on that allow you to really run a horizontally scalable system versus these individual little single node things. But yeah, basically, when you run out of when your nodes are just completely full, then you definitely have to do it. And the original idea was really to not have this one huge Prometheus in your infrastructure, but just have many. But I realized, like actually, like Prometheus server, a single one, a big one, can get you quite far initially when you start out. So there's always a big hesitancy to like draw it more, and then like, okay, I guess we need to shard it. But at SoundCloud, we really did it like more in a functional sharding way, right? Like every team had their own ones, or like for the different services. And sometimes even with single services too large, and then you start like this hash mark sharding, I guess, like where you have like 10 Prometheus servers monitoring the same service, but only a subset of like a 10th, where you have a relabeling rule, you know those?
No, sorry.
Ah, okay. There's like in the config file, you can say generally discover all the targets of this service, monitor them all, but only the first chart. Like you can hash together you can produce a hash for, let's say, of the instance label, and then create the modulus of that and say, okay, only keep the targets where the modulus is 1 in this first instance, and then modulus is 2 in the second one, and so you can filter. And then you have a sharded setup, but then your data is even more fragmented. So you even more need some layer on top that helps you make sense of it again. Yeah. Or you use a cloud service and just send everything there. Like Amazon, Google, Grafana, Chronosphere, there's so many different Prometheus companies.
That's what I saw, so that some people suggested the Grafana agent to say, yeah, install this one and send everything up to your endpoint.
Yeah, if you're using Grafana Cloud, for example, but the Grafana agent also uses this protocol that's part of Prometheus remote write to allow you to send data locally, just collect it, but don't even store it locally at all in your Prometheus server. There's no Prometheus server anymore, but just send it to a cloud. It's like funny, like some of the bigger Prometheus setups don't even have a Prometheus server anymore. They just use some agent locally to scrape Prometheus format, send it to some cloud vendor that supports Prometheus data style and the Prometheus query language, but there's no vanilla Prometheus server anymore. So just a set of different interfaces that are open now and that many people are implementing. Alrighty.
Any more
Any others?
questions? Was Julius is here.
Okay, thank you very much.
Thank you.
Thank you for the invite.